Okay, let's go ahead and go over the Graphing 2 assignment. In this Graphing 2 assignment, there's actually several sections, and each section is slightly different. So let's go through each section one at a time. Numbers 1 through 4 is just solving, they're just solving equations. So in order to solve an equation right here, you'll want to think of the equal sign as a wall, okay? In this wall, you're only looking for where you're trying to solve. What are you trying to solve? You're trying to solve for the V right there, okay? Well, with that V, picture it inside a box, and this inside a box, and this inside a box. We've got to get that box all alone on this side of the wall. So with it being on this side of the wall, we don't even need to worry about the other side of the wall, okay? All we want is just this side of the wall. In this side of the wall is the V alone, or the box with the V, excuse me, the whole box. Is it alone? No, we have that plus 7 right there. So we need to get rid of that. We actually have minus 7, excuse me. So we need to plus 7. Whatever we do to one side, we do to the other, and we're left with 32 equals 4y. Okay, now once again, just on that side, is that box now alone? And the answer is yes. We got rid of the minus 7. There's nothing else there. The box is alone. So we can take the box apart and say, okay, now we got to get rid of the 4. Those are connected by multiplication. If those are connected by multiplication, we're just going to divide by 4, and we see that y equals, what's 32 divided by 4? 8. So y equals 8. Okay, let's go over to number 2. This one, they threw in a little trick here. You've got to distribute this negative 6 throughout. So this side we're not touching. Negative 3x equals negative 30 minus 6n. Because negative 6 times 5 is negative 30. Negative 6 times n is negative 6n. Now we look at it and say, okay, is the box containing the n all by itself? And the answer is no, it is not. Okay, make it a little easier to see. It is not. Right now we have that negative 30 sitting right there. Okay, so we need to get rid of that by doing the opposite of whatever is in the box. If it's negative 30, we're going to plus 30. We have to do it to both sides. Now we have negative 6 equals, and what's left? Just a negative 6n, okay, because that negative sign is still there, so it needs to still be there. Now, everything else is away, so we're just going to divide by negative 6 to get the n by itself, and we see that n equals 1. Okay, let's go straight down to number 4. Actually, we'll just keep going in order. The trick to this one is the a is in a fraction. Okay, when it's in a fraction, you have to think to yourself, okay, first step is getting the fraction by itself. Is the fraction by itself? Now, the most common mistake is going to say, no, there's a 4, or there's a negative 7, or something to that effect. And you don't want to fall into that trap, because those aren't with the fraction, they're part of a fraction. So it'd be the same as me saying, is this a box of Cheerios? No, this is a box of wheat and flour and sugar and riboflavin and all the other stuff that goes into Cheerios. Don't go into that detail. Just look at it and say, is this box the fraction? Yes. Is the fraction alone? Yes. So step 1 is done. Step 2, get rid of the fraction by multiplying by whatever's in the denominator. So in this case, there's a 4 in the denominator, so we're going to multiply both sides by 4. Doesn't matter what's in the numerator, just the denominator, because now we can cross cancel the 4's, and we're left with just a minus 7. That's an A. I'll do a capital just so you know the difference. A minus 7 equals what? 2 times 4 is 8. Okay, now we got the fraction all gone, and we need to ask ourselves, is the A alone? The answer is no. We still have to add the 7. Now we have A equals, and what does A equal? 8 plus 7 is 15, and we're done. Okay, number 4. Get all the pieces in a box and say, all right, and I know there's writing up there, so I'll cover that up, and say, all right, in that box, or in those wall, which side of the wall is the R on? It's only on the right hand side. Okay, now we're only looking at the right hand side. Is that fraction alone? That's step 1, because R is in a fraction, so step 1 is get the fraction alone. The answer is no. There's a 5 over here, a negative 5, minus 5. So whatever we do, we've got to get rid of that by doing the opposite. So we're going to plus 5. That gets rid of the minus 5. But whatever we do to one side, we have to do to the other. And we are left with 3 equals R over 4. Okay. Now is the fraction alone? If we look at it and we say, okay, just on that side of the wall is the fraction alone? Yeah, I don't see anything else with it. So now we can clear it out. Multiply by whatever's in the denominator. In this case, it's a 4 right here. So we can cross it off, and we're left with 4 times 3 is 12 equals R. Just 4 times 3 equals R. And that's the answer to number 4. Okay. And let me move these papers. There we go. That's a little better. All right. Number 5. We're moving on to graphing here. Y equals 5x. Okay. We need this in the format of y equals mx plus b. Okay. Now we have the y equals something times x, but we don't have the plus b. So what does that mean? Well, that just means we don't have anything there, plus 0. Okay. Well, plus 0 means it's crossing the y-axis right here when y is 0. And what's our slope? Our slope is 5 over 1. So we're going to go up 5 and over 1. And that gives us a line that goes straight up, not straight up, but up steep like that. Okay. Now let's move over to number 6. Remember, y equals mx plus b. The plus b right here is the y-intercept. And the m is the slope. Okay. Well, which one's our y-intercept? Right here, positive 3. So we're going to go up and draw a line right, or a dot right there on the y-axis at positive 3. And what's our slope? Well, there's only one x there. So draw a line and put a 1 under it to make it a fraction. That tells us it goes up 1 over 1, up 1 over 1, and so on. And again, we have a nice line. Okay. Now, keep in mind, the line needs to go through the whole graph. Okay. Not just a piece of it. So that's how you do numbers 5 and 6. Number 7, it adds the inequality to it. Okay, so we can see right here that it's not equal, it's greater than or less than or equal to, something like that. But for now, just pretend that's an equal sign. Okay, so just for the sake of helping you out, let's pretend that's y equals. Okay, well with that in mind, where's our y-intercept? Our y-intercept is positive 2. And what's our slope? Down 1 over 2. So down 1 over 2. Now what if you put the negative on the 2 instead? That's okay. Up 1, negative 2. Notice it's the same line. Okay. Now we're done with plotting the points. So we go back to the y inequality, and we say, okay, there's a line underneath there. You see that equal to sign right there, that line? That tells us it's a solid line. So with that in mind, we're going to go ahead and graph that with a solid line. Okay, and with the solid line, we need to know, do we shade up or down? Okay, there's two ways to figure this out. You can, less than is always shading down. Okay, so it shades all of that. So less than means we're shading all of that. Okay, now there's another way to tell. Okay, and that's to turn the y into a 0, like that, and ignore the x, and say, is it true that 0 is less than a positive 2? And the answer is yes, 0 is less than positive 2. If that's the case, that means 0 right here has to be part of the shaded side. And so you see how that's part of the shaded side right there? We have to shade down. So you just shade in this side. Okay? Now let's look over here. X is less than 2. Now, with x is less than 2, we're missing a big piece right here. We're missing a y. That tells us that it will never, ever, ever cross the y-axis. So that means there is no y-intercept because there is no y in the inequality. Well, if that's the case, what do? That means it's got to be parallel with this line right here, the y-axis. Parallel means it never crosses. It's always the same line, just move sideways or whatever. And so we need to draw a line at what number? Positive 2. And it's a dashed line because there's no line underneath the inequality. So we're going to say, okay, dash, 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 a straight line all the way down. Okay, now which side do we shade? This side or this side? Well, which number is less than 2? 1 or 3? 1 is less than 2, so we would shade that side. Now another way to do it again is to ignore it and just say, is 0 less than 2? If the answer is yes, then you need to make sure that that is included on whatever side you shade. So it has to be included, so we're going to shade that side. Okay, so that's number 8. Number 9. Here we have the same thing. Again, we're just trying to plug in y equals instead first, just to graph it. So if we do y equals, our y-intercept is right here. So we know it crosses the y-axis right here at -4. And what is our slope? Our slope is 6. If it's a whole number, just draw a line, put a 1. So it goes up 6, 1, 2, 3, 4, 5, 6, and over 1. Okay, so we have our 2 points. Now we look at it and say that is a dashed line because there's no line underneath the inequality sign. So it's a dashed line, and it's along those 2 points. Okay, now do we shade above it or below it? Less than is everything below the line. Okay, so everything below the line is shaded, telling us that any of those points are work for the answer. Now again, we can look at it and say, all right, we're going to put 0 here and ignore the x. Is 0 less than -4? And the answer is no. 0 is not less than -4, which means 0 cannot be shaded. And notice it is not shaded. Okay. Okay, number 10. Again, ignore the inequality at first and just say, all right, y equals, what does y equal? Well, there's our y-intercept, so positive 2. We're going to go positive 5, positive 2, so up 1, 2, 3, 4, we can't. When we can't go up the full amount, we put a negative sign on both of them, the numerator and the denominator. Because think about it, a negative divided by a negative is still a positive, so we didn't change anything. So we're going to go down 5, 1, 2, 3, 4, 5, and negative 2. And that puts us right here. Okay. Now we're back to inequality, and notice the line under the greater than, making it greater than or equal to. With that, we're going to draw a solid line. Okay, so now we have a solid line. Do we shade below it or above it? It says greater than. Greater than is up, so everything above it gets shaded in. Now if we don't remember that, we can say, okay, put the 0 in, ignore the x. Is 0 greater than 2? The answer is no, so whatever side you shade cannot include the 0. So notice we shaded the other side so that the 0 right there is not shaded. Okay, so that's how you do up to number 10. Number 11, these ones are just to remind you how to graph an inequality on a number line. We're going to positive 1, and we're going to draw a circle. Is it a solid circle or hollow one? It's a solid one filled in because it's including number 1. See that little line underneath there? And it's greater than 1. So we're going to draw our arrow. Okay? So right below it, r is greater than 3. It's a hollow circle because it's greater than but not equal to, so it's not included. And then we're going to draw our arrow. Greater than means it covers all the numbers bigger. Okay, number 12. Number 12. In this one, we're drawing a circle in number 2. Is it hollow or filled in? It's going to be a hollow circle, and it's less than 2, so less than is everything that direction. Now, if you don't remember which way to draw it, just look at which way that arrow is pointing. Okay, the greater than, less than is pointing to a direction. It's pointing that way, so you need to shade everything that way. So we're going to draw a circle at negative 4. Negative 4 says, all right, it's a hollow circle because there's no line there. So now we're saying greater than, so it's everything that direction. We know it's that direction because that's the direction the inequality sign is pointing. Okay? All right. Number 15. 15 through 18. These pretty much need to be done inside school where you have access to a graphing calculator. They don't have to be. It's just a lot easier. So what I'm going to do is I'm going to show you the first two done with a graphing calculator. Then I'm going to show you the last two done without a graphing calculator, so you can see the difference between the two. Okay, and so you can see how to do it without. Okay, so I'm going to zoom out so we can see the graphing calculator. And in this, what I want to do is go into the equation. You hit the y equals, and then I'm going to enter the equation. So it's negative 2x squared plus 4x minus 6. Okay, and now what I want it to do is create a chart or a table. So you can see tables right there on F3 or F5, excuse me. So now I'm going to hit second table, and it creates a table for me. All I need to do is look at it and say, okay, what is the minimum my graph goes to? Negative 13 right down here. It doesn't go any lower than negative 13. So all my y's that I can graph need to be above negative 13. So I'm limited to what I can graph. But with this table, I'm going to say okay, and I'm just going to copy it right off the calculator so I can move it. But I want negative 12 because that's less than negative, or between negative 13 and 13, or 0, excuse me. So when x is 1, or negative 1, when x is negative 1, y is negative 12. Okay, so you see where I'm getting that. I'm just copying down what's right there. When x is 0, y is negative 6. When x is 1, y is negative 4. And when x is 2, y is negative 6. And when x is 3, y is negative 12. So all I did was just copy these down. So negative 1, 0, 1, 2, 3, until I got to the negative 12 again. I can't go below negative 12, so those last two don't really need to be there. And that's where I got those numbers. Now with that written down, I can look at it and say, all right, this, by the way, is showing your work for this type of problem. Just writing the table is showing your work. So when you're asked to show your work, do this. When x is negative 1, y is 12. So our x goes back and forth, and if you forget, it's just right there, and y is right there, telling you which one's which. When x goes to negative 1, so we're on x negative 1 right there, y is 12. So negative 1, we're going down to negative 12. And we're going to put a point right there. When x is 0, y is negative 6. So when x is right here at 0, we're going down to negative 6. When x is 1, so positive 1, y is negative 4. We're going to put a point right there. When x is 2, so here we are at positive 2, y is negative 6. Y is negative 6 again. And when x is 3, y is negative 12. So 3, and then down to negative 12. And we can see the U shape forming. Now, remember, this is not a point at the top. It's a U. It's a nice curve, not a pointy shape. And that's all you need to do there is just sketch the graph. Okay? So let's look over at number 16. If we go to number 16 and we enter in the equation and say, okay, we want 1/2 or 0.5. I'm just going to do 1 divided by 2. On these calculators, when you do a fraction, do them in parentheses, times x squared plus 2x plus 1. Okay, and then we're going to hit second table, and that gives us our table. And again, we look at the y. Our y goes from negative 3 to 3, but our x, notice our x only goes to positive 1, but then down to negative 5. Okay, so we need to keep that in mind. Negative 5 is the lowest we can go on our x. Okay, so let's write down the table. And we can only go y to the 3's and x to the negative 5's. So there's x to the negative 5, but notice the y goes above 3, so we can't use that one. So let's go down to the next one. When x is negative 4, y is 1. See that right next to the negative 4? When x is negative 3, y is negative 0.5. Negative 2, so I'm right here on negative 2, y is negative 1. When x is negative 1, y is negative 0.5. When x is 0, y is 1. Okay, and then we're back above 3.0, which we can't do. We got to just stay there because we can't go above 3. Okay, so now I showed my work, And I can say, all right, when x is -4, so here's -4. Remember, we do the x first. Y is 1. So we're going to put a point right there. When x is -3, y is -0.5. When x is -3, y is -0.5. When x is 2, y is -1. When x is, -2, y is -1. When x is -1, y is -0.5. When x is 0, y is 1. So we start to see that U shape again. Just like that. Okay. Now let's say I don't have a calculator. Okay. I don't have the fancy graphing calculator, and so I need to do it all by hand. That is definitely possible. Let's go ahead and make our t-chart. And let's say, okay, we want negative, or where are we starting? Our x's are going to start at 0, then 1, 2, 3, and let's see if we can get far enough there. So let's plug in 0. 0 squared is 0, minus 18 times 0 is, or 8 times 0 is 0, plus 12, so that's 12. Okay, let's plug in 1. 1 times 1, or 1 squared, is just 1. 1 minus 8 times 1, so 1 minus 8 is -7. -7 plus 12 is 5. Okay, next, let's plug in 2. 2 times 2 is 4. 4 minus 2 times 8 is 16, so 4 minus 16 is -12. -12 plus 12 is 0. Now let's plug in a 3, and I'm just plugging it in and doing the math. 3 times 3 is 9. 9 minus 24, because 8 times 3. So 9 minus 24 is -15, and you can do that one on the calculator, just any calculator. -15 plus 12 is -3. Okay, let's see if we can see what's going on here. We have 0, 12, 0, we can't go up to 12. 1, 5, can't go up to 5. 2, 0, that one we can do. So we know it's coming down, right? 3, -3, so 3, -3. Okay, we still don't quite know where it's going to stop, so I'm going to add 1. I'm going to go 4. What's 4 times 4? That's 16. Okay, 16 minus 32. And I'm getting the 32 from 8 times 4. Okay, just plugging the 4 into the x. 16 minus 32 is -16. -16 plus 12 is -4. So now when we go to 4, we go down to -4. I'll bet that's going to be the bottom. Let's see. Let's try 5. 5 times 5 is 25. Minus 5 times 8 is 40. Okay, 25 minus 40 is -15. -15 plus 12 is -3. Okay, so we can see now, we can stop, we can see, all right, that's going to go kind of like that, and then back up. Okay, and we don't have to keep going. Okay, let's go ahead and make a table over here for 18. Okay, and again, we're doing this one as if you don't have a calculator that will graph it for you, and that's perfectly fine. So x, y, what are our options on x? All the way from -4 to 4. So I'm just going to choose a couple easy ones. I'm going to do -2, -1, 0, 1, 2. So just write these 5 right here in the middle, and I'm going to plug them in. So negative 2 squared is 4. So now we have a negative 4. Let's write it down so we don't get confused. Negative 2 squared minus 2 times negative 2 minus 5. Okay, so let's just do the math. Remember, order of operations. Exponents first. Okay, so negative 2 times negative 2 is 4. So we have 4 minus, what's 2 times negative 2? Well, that's a negative 4, which is going to be plus 4 because minus a negative. Okay, and then minus 5. Negative 4 plus 4 is 0, so we have negative 5. So we have negative 5 here. Okay, now let's plug in negative 1. Negative 1 squared minus 2 times negative 1 minus 5. So you can see all I'm doing is plugging it in. Just plugging in the negative 1 for the x's. Now do the exponent first. Negative 1 times negative 1 is 1. Minus 2 times negative 2 times negative 1 is positive 2 minus 5. Okay? Because remember, minus a negative is the same thing as plussing. Negative 1 plus 2 is 1. 1 minus 5 is negative 4. Okay, so we're going to put a negative 4 there. Now let's plug in a 0. Negative 0 squared minus 2 times 0 minus 5. Well, that's 0. That's 0. Minus 5 is negative 5. Okay, now let's plug in a 1. Negative 1 squared minus 2 times 1 minus 5. Okay, again, just plugging in the 1 for each x, and we're going to say, okay, 1 squared is 1, so now we have the negative 1 minus 2 times 1 is just 2. So negative 1 minus 2 is negative 3. Negative 3 minus 5 is negative 8. Now if I keep going, I'm going to go well below that bottom negative 9, and I don't need that. Okay, so I'm going to go ahead and stop. We're not going to worry about the 2. And we can see, all right, when x is negative 2, y is negative 5. So negative 2, negative 5. Put a point. When x is negative 1, y is negative 4. Put a point. When x is 0, y is negative 5. Put a point. When x is 1, y is negative 8. And we can start to see where this graph is going to go. A negative view down there. So as you can see, it's much easier to just use the calculator, but either way you can solve it. You don't have to have a calculator. It just makes things much, much easier if you have a calculator that can solve it. So that is the very long graphing 2 assignment. I hope this helps. Remember, you have a full week to do it and turn it in. Let me know if you need more help.